Hi guys, Mrs. Suoja here. These notes are going to cover section 1.2 of our geometry textbook. And you may want to pause the video and try to answer the questions on this opener. I'm going to go ahead and get started. So the first question we're going to answer is to give two names for this plane. So this plane is the plane that's represented by this parallelogram here. Parallelogram looking shape. And what we want to do is just name any 3 points on the plane. And at first, we have to put on some geometry eyeballs. So A looks like it's on the plane. This line is supposed to be coming straight down through the plane and piercing through it, and that's why it's dotted right here. And the C is ending up below the plane. And even though this A looks like it's drawn onto the plane, it really is on a line that's not resting right on the plane. So that part is a little bit confusing. But to me, when I look over here, this would be have no other choice but to be on the plane, and these other points right here are on the plane. Okay, so when we name a plane, we may have to name it with 3 non-collinear points. So, for example, I'm going to name it plane, and I'm going to just pick 3 points that are not in a row. H, G, E. So H, G, and E, they're not in a row. That means they're non-collinear. That would name the plane. Another option, and there's lots of different options for this one. B is actually on the plane. It's the point where the line pierces through the plane. So B, D, E would work. Plane B, D, E. I won't name any more, but any collection of 3 non-collinear points from the points that are on the plane would work. Okay, now we're going to name a pair of opposite rays. So opposite rays share an endpoint. They have the same endpoint, and then they go in exact opposite directions. And just a reminder that when you name rays, they are always named like this with the symbol pointing to the right. So I'm going to choose point B and name the ray that goes up, which is ray BA. And now, before I even look, right, I know that my other ray has to start with point B, because that means they have the same endpoint. So the other ray is the ray that starts at B, and it goes down through C. So this is a pair of opposite rays. Okay, question 3. This is line AC intersects the plane at what point? So AC is piercing through the plane at point B, capital B to name a point. This is line HG and line GE intersect at what point? At. Let's see, so HG and EG or GE intersect at point G. Name 3 collinear points. That means 3 points that are all in a row. And it looks like my only option is point A, B, and C. They're all on that same line, A, B, and C. And then our points F, D, E, and B coplanar. Okay, so that means coplanar all on the same plane. So, I mean, F is not on the plane that's shown. Let's see where these other points are, D, E, and B. D, E, and B are all up on the plane, and F looks like it's resting below. So no, not on the same plane. Whoops, no. Sorry. Okay, now we'll kind of begin the section 1.2 notes. All right, so our first vocabulary word of the day is a postulate or an axiom. They are just 2 vocabulary words that mean the same thing. Our book kind of uses them interchangeably. So definition is a rule that is accepted without proof, as in without being proven to be true. We're going to get our first postulate today, so I will talk about that when we get to it. All right, and then a theorem, by comparison, is a rule that is proven to be true. And just an example of this would And I'm choosing this because it seems like a famous theorem that people already know by the time they get to geometry, and that is the Pythagorean theorem. All right, so it says this: a squared plus b squared equals c squared. This is the rule that goes to the lengths of sides of right triangles. And it's a rule. In this case, it's an equation. And it's proven to be true by Pythagoras or by people in his school. All right, so onward we go. So some more kind of terminology and symbols and definitions. We have something called congruent segments. So congruent is another way to mean equal. All right, so it's like saying equal segments. All right, and segments that have the same length or measure. All right, and there's a symbol for congruence, and it is this. It's an equal sign with a little squiggle over the top, called a tilde, I guess, but this is the new symbol. All right, so we'll draw a few pictures over here. So let's go ahead and draw segment AB and segment DF. All right. Now, symbolically on a picture, the way that you show when two segments are congruent is with tick marks. Okay, so that's important. This is kind of a big thing in geometry. Tick marks indicate congruent segments. And the way we would make a statement about this is we would say segment AB, segment line over the top, is congruent to segment DF. So without any numbers on here at all, these tick marks say their segments are congruent, and this is a statement that also says the two segments are congruent. Okay, now let's draw a slightly different diagram. We're going to have segment AB and segment DF, but in this case, I'm going to put numbers on these segments. All right, so what we would say about these two segments, because now we have measures, is we would say AB equals DF. So when you don't put the little bar above it, this is like saying that the measure of segment AB is equal in length to the measure of segment DF. I know it seems like we're saying the same thing in the beginning. It does kind of seem like the same thing, but you get used to it. When you're working with numbers, you don't put the bar over the top. When you're just simply talking about two segments being the same length without any numbers, then you put the bar over the top and you use the congruence symbol. All right, and one other thing to add on here is I could also make a statement that says AB is equal to 12. So notice, because I'm saying that this has a measure of 12, I don't put the bar over the top. And DF equals 12. Okay, this is labeled as example 1, but this really is more like more terminology. This is another vocabulary word, between, which I know doesn't seem very complicated, but there is one little one thing you have to keep in mind. In order for you to say that one point is between two other points, the 3 points have to be collinear, as in they have to be on the same line. Okay. So there's the two comparisons right here. Is B between points A and C? So as long as they're all collinear and B really is between them, then we can say yes. Because A, B, C are collinear on the same line. Okay, however, by comparison, on this diagram, E is technically not between D and F because E is not collinear with D and F. No, E is not collinear with D and F. All right, so to be between the 2 points all have to be on the same line. The 3 points have to be on the same line. Okay, now we're just going to visit our first postulate. First postulate. So a postulate, a rule that is assumed to be true, not proven to be true, and typically postulates are very basic. They're very straightforward, and they're very believable. So sometimes you're like, why do we need to write a rule for this? Everybody can see it. So our first one is called the segment addition postulate. And in words, that means when two segments along the same line are added together. And we're going to draw a picture of it. So let's draw a line. All right, and we're going to do 3 points, 1, 2, 3, all in a row. We'll name them A, B, and C. All right, so what segment addition postulate says is that I could take that segment right there, AB, and I'm just going to call it AB. And when you do arithmetic, you don't put the bars over the top. You're just talking about measures. So the measure of AB plus the measure of BC, add those two segments together, that has to equal the measure of the longer segment, which is AC. Okay, segment addition postulate. So it totally makes sense, right? You take the two smaller segments, add them together, and they have to equal the longer one. Okay, so example 2 says, use the diagram to find KL. All right, so first thing about this is that to find KL, we look over here and we're like, it's right there. All right, this is meaning for you to find the measure or the length, measure or length of KL. So we're looking for an actual number for the answer. And we are going to do this, even though I know a lot of you are like, I know I just have to do 38 minus 15 and I'm going to get the answer. We're going to use the segment addition postulate. And it's important that you get used to doing this because in geometry, you have to set up a lot of your own equations. And so we should start with the little ones while they're easy, getting used to doing that. All right, so segment addition postulate says that segment JK plus segment KL has to equal segment JL. All right, so JK is 15, KL we're trying to find, JL is 38. So now we've got an equation and we're just going to solve it. So we'll subtract 15 from both sides and we're going to get 23. Okay, I know it seems simple, but basically that is the segment addition postulate being applied to an actual algebra problem. All right, and last example, we're going to write and solve an equation for this diagram. All right, so these two segments, this segment from A to B is equal in length from this segment to this segment from C to D. And again, I feel like this isn't quite right. If you use the bar, you're supposed to use the tilde. You're supposed to use the congruent segment. So this is saying the two segments are congruent. And when you do arithmetic, typically you have it as AB is equal to CD. These two lengths are equal, and we're going to use algebra to show that. Okay, so segment AB is composed of this segment and this segment together. All right, the 4 times x plus 1 segment plus the 5 times x plus 1 segment. So we're going to add those two segments together, and those have to equal the CD segment. So that's these two segments added together. 4 times x plus 3 plus 3 times x plus 3. All right, so there's the equation. And now we're just going to solve it. And if you want to just pause and solve, then you can follow along with me. I'm going to go ahead and let the video run, I guess, but if you don't need the solving help, then you can go ahead and fast forward through it. So we'll distribute, combine like terms with these x's are on the same side of the equal sign, so 9x plus 9, 7x plus 21. All right, now I'm going to subtract 7x from the right. Subtract 9 from the left. Divide away the 2. Kind of ran out of space, but x equals 6. Okay, and so I think we answered our question, right? We solved for x. All right.